Hi, this is Ms. Goodman, and I'm going to go over a few questions that several students missed on the Module 3 homework assignment over sections 5.1 through 5.4. I'm going to use the questions that are given on the handout I've provided. The first question is question number 7. This says to simplify 9 to the power of 10 times 9 to the power of 7, and to write your answer in index form. This is the same as exponent form, or writing the answer raised to a power. Well, first you should note right away that the bases here are the same and that we're multiplying. So when the bases are the same, 9 and 9, and when we're multiplying those bases, then we can apply the product rule for exponents, which says that any base raised to a power times the same base raised to the same or another power is equal to that base raised to the power of the sum of the exponents. Okay, so this means that following this rule, where our b's are 9 and our m is 10 and our n is 7, we can write this as 9 raised to the power of 10 plus 7. We add the exponents. When we multiply like bases, we add the exponents. And that is the same as 9 to the power of 17. And that's the answer. The next question is question number 9. Question number 9 says, simplify 5 times y to the power of 4, all raised to the power of 4. Okay, so whenever you see a power to a power like this, a 4 to a 4, apply the power rule. The power rule says that if you have a base raised to a power, raised to another power, you multiply the bases, m times n. Now here we have two bases inside, a 5 and a y. The 5, if we rewrite this, is raised to the power of 1, the y to the power of 4, but both are raised to the power of 4. Okay, that's just to understand it a little better. Now, applying the power rule, we multiply this 4 here by this 1, and this 4 here by this 4. So we have 5, 4 times 1 is 4, y to the 4 times 4 is 16. Okay. And then we evaluate 5 to the power of 4, which is 5 times 5 times 5 times 5, y to the 16, which is 25 times 25, y to the 16, which is 625, y to the power of 16. And that's our answer. Question number 10. Simplify 2 times y squared, all raised to the power of 3, times 3 times y cubed, all raised to the power of 3. Okay, this is just like the previous problem, only we're going to apply the power rule to this first term and to this first factor and to the second factor. So if you recall, any base raised to a power raised to another power is that base raised to the product of those two powers. So here again, we're going to multiply these exponents. So we have 2 to the power of 1 times 3 is 3. Y to the power of 2 times 3 is 6 times 3 to the power of 1 times 3 is 3. Y to the power of 3 times 3 is 9. Now we evaluate 2 to the power of 3. That's 2 times 2 times 2, which is 8. Y to the 6th times 3 times 3 times 3 is 27. Y to the power of 9. Now, note, we have two y bases multiplying together. Same base, multiplying. Going back to the first question we did, we apply the product rule, which says b to the power of m times b to the power of n is b to the power of m plus n. So when we multiply like bases, we add the exponents. But first we need to multiply the 8 times the 7, 8 times the 27. And that is 216. And then the y to the 6th times the y to the 9th is y to the 6 plus 9. So we have 216 y to the 15. And that's our answer. Question number 11 says consider p of x, it's a function of x, is equal to 3 times x to the 5th plus 2 times x to the 6th minus 8. And part A says find the value of p of 0. Okay, to find the value of p of 0, all the x's are replaced by 0. Now you know that 0 times anything is 0, so these are both zeros. And that just leaves us with minus 8, which is our answer for part A. For part B, we're supposed to find p to the power of 1. Sorry, p of 1. So replacing the x with 1, replacing the x with 1. 1 is raised to the 5th power. Replacing the next x with 1, where 1 is raised to the 6th power, minus 8. Okay, so these are the x's. I've replaced them with this value of 1. So p of 1, is 3 times 1 plus 2 times 1, because 1 raised to the power of anything is 1. 1 times 1 times 1 times 1 is 1, etc. So minus 8. And that's just equal to 3 plus 2 minus 8. And 3 plus 2 is 5 minus 8 is minus 3. So that's our answer for part B. Finally, on part C, you're going to find p of, got it right this time, minus 4. putting this into the equation that you still see on the handout. 3 times, I'm going to replace the x with minus 4. And that whole minus 4 is x, so that whole minus 4 is raised to the power of 5. Plus 2 times, again, the whole minus 4 is the x, so the whole minus 4 is raised to the power of 6. It's important to put those parentheses. Minus 8. Okay, now it's just a matter of evaluating. Do that very carefully. You know that a negative base raised to an odd power, because there's always that odd factor out, and negative times a positive is a negative. When you have an odd power and a negative base, you're going to have a negative result. So it's just a matter of knowing what 4 to the power of 5 is. So you can do that. You can do that on your calculator. You can go 4 times 4 times 4 times 4 times 4. I'm going to go 4 to the power of 5. I have 3 times minus 4 to the power of 5 is negative 1, 0, 2, 4. Plus, now I have negative 4 to the power of 6. And that's an even base, that's an even exponent, an even power. 6 is even, so we're going to have a positive result. And 4 to the power of 6 is 4096. I'm evaluating this line now. 3 times negative 1024 is negative 3072 plus 2 times 4096, 8192 minus that 8. Don't forget that minus 8. Okay, now we have a negative 3072 plus 8192 minus 8. So we're going to go minus, I'm doing this on my calculator, 3072 plus 8192 minus 8. And I have 5,112. And that's the answer. Let's see. Next one is number 12. Question 12. Question 12, looking at the handout, says, oh, that's a big long one, simplify x minus 3 minus 3x cubed minus, I'm going to have enough room here, minus 3x cubed minus 4x squared plus 9x plus 8 plus, I'm going to have to go on the next line, minus 9x cubed plus 3x minus 5. Okay, now first thing to do, I'm going to take baby steps here, is wherever you have a negative sign outside parentheses, that negative sign means opposite of. Take the opposite of all the signs inside the parentheses. So we're going to do that for that the second set of parentheses here. Okay, this set right here. So I'm going to keep everything else the same. Now this plus sign right here, outside these parentheses, that preserves all the signs inside, so I can safely drop those parentheses. And I can drop the first set of parentheses. So that's going to become x minus 3, and safely drop those parentheses because there's a plus sign outside here. But the next set is where all the signs inside change to the opposite sign, because this is like a negative 1 here. And it's that negative 1 is multiplying by each of these. Okay? So we have negative times a negative is going to give us a positive 3x cubed plus negative times the negative again. Negative 1 times the negative 4x squared is a plus 4x squared. And then we have negative 1 times positive 9x, which is negative 9x. And then a negative 1 times the positive 8, which is negative 8. And again, this positive sign here preserves, so we can safely just drop the next set of parentheses. And inside those parentheses is minus 9x cubed plus 3x minus 5. Okay? Now I'm going to collect my like terms. I see here I have one set of cube terms. Put those in like shapes. And I have an x squared term here that's all by itself. I have x terms, I'll put those in squares. And I have to not lose track of the signs in front of the terms, because they go with the terms. They're like the terms' noses. Okay, so I have another x term here. And I have these two number terms. I'll just check mark those. Let's start with the highest power first, because that's normally how we write polynomials in a descending order. So we have a 3x cubed minus a 9x cubed. That's minus 6x cubed. And then we have in the triangle this 4x squared. There are no like terms for this one. And then the x terms. I'm going to add my positive ones first. I have 1x plus 3x is 4x. Minus 9x is minus 5x. Right? 4 minus 9 is minus 5. Or 9 minus 4 is 5, but the bigger absolute value is negative, so the answer is negative 5x. And then the numbers, I have another number here, just overlooked. I have minus 3, and a minus 5 is minus 8. Okay, altogether I have 8 negatives. But I have 8 more negatives over here, so that's 16 negatives. So it's minus 16. Okay, just looking everything over carefully. All right, and we have no more like terms to combine, so this is our answer. This is that I combined these three polynomials to get this one polynomial here. It's an answer. Okay, a couple more questions. The next one is question 13. Expand 6x minus 1 times 6x plus 1. Okay, here I'm going to use FOIL, which simply says I multiply the first term times the first term, the outer terms times the outer terms, the inner term times the inner term, two inner terms together, and the last times the last. So that's FOIL, first, outer, inner, last. But it's a common sense method. I go the first term times the first one, and then the first term times the second one in the next parentheses. And then the second term in the first set of parentheses times the first term in the second parentheses, and the second term in the first parentheses times the second term in the second parentheses. It's a common sense order, though the order really doesn't matter. The answer should come out the same in the end. So 6x times 6x is 36x squared. 6x times 1 is 6x. 6x, minus 1, now I'm doing the inners. Minus 1 times 6x is minus 6x. And finally, the last times the last. Minus 1 times 1 is minus 1. Okay, now you can see here, this is actually a special product where we have both set of parentheses look exactly the same, except the sign on the second terms are different. So what happens is these two middle terms here end up having opposite signs because the outer is positive 6x and the inner product is negative 6x because of these opposite signs here. So these middle terms cancel out, and we're left with 36x squared minus 1. Really, all we had to do for this special product was to square the first term here and this one here, square them. 6x squared is 36x squared minus 1 squared, or just 1 squared is 1. But we put a minus sign always here because these two here have opposite signs. Okay, so squared, whenever you see the exact same parentheses and the last term is just a different sign, you just square both of the terms and put a minus sign in between. Okay, that's called the difference of two squares. Be important for the next topic on factoring. Okay, moving on to the last question, question 15. Not a whole lot of people missed this one, but I was surprised because this takes some doing, and I wanted to show you maybe a practical way of doing this problem. And that is to leave this first bracket the same and then put a larger bracket here where you're going to put the result of squaring these two. So x times x is x squared. X times 5 is 5x. Minus 2 times x is minus 2x. Minus 2 times 5 is minus 10. Okay, now I'm going to copy this again and combine the middle terms because they're like terms. X squared plus 3x minus 10. And now I'm going to do extended FOIL. I'm going to do the first times the first times the second, and the first times the third. And then I'll do the second times the first, the second times the second, and the second times the third. So x times x squared is x cubed. We're multiplying like bases, so we add the exponents. We add this 1 to the 2. Okay, so we have x to the third. X times 3x is 3x to the second, because we have an x to the power of 1 times the 3x to the power of 1. So that's 3x to the 1 plus 1, which is 3x to the second power. X times minus 10 is minus 10. Moving on to the 3 here in the first parentheses, multiplied by each of the terms in turn in the second set of parentheses. 3 times x squared is 3x squared. 3 times 3x is 9x. And 3 times minus 10 is minus 30. So all we have to do now is combine like terms. We have these two 3x squareds, that's 6x squared. A single 9x. And then we have minus 10 here and minus 30, which is minus, altogether minus 40. And that's our answer.